Hi, I'm just going to talk through my code for 888-527. This is by Andrew Bingham and Michael Davidson. Within this project we're using the freeRToS setup. So you'll see within the header files here we have all our standard freeRToS header files, as well as that we've got our standard freeRToS source files. So we've got our tasks, queues, the standard ones. So if we just have a wee look into our main project for network, we've got our standard libraries X include plylib, which is needed to run freeRToS or freeRToS files, and then we've also got this network config header file. So we take a wee look in here. So we've got our setup for the UARTs, and we're defining our clock speeds, configuration settings for the UART1. So some of the main things in here, it's idle when it's high, it's a time 16 mode. Then we're down here, we're just enabling our transmit and receive bits. And then again, we've got the same thing then for UART2. On down again, then with serial transmit 1 and serial receive 1. So in here, it's just taking the string and putting it into the buffer, then incrementing buffer, decrementing size, and wait until the transmission is finished before transmitting it out to the POTI. And then receive. So within the receive, we've got our while loop here, which waits until the data is available in the receive buffer, takes the value from U1x and puts it into the buffer, and if the buffer has a return or new line, it breaks, and then increment buffer and number character. And again, we've got the same thing for our transmit and receive for our other UART, and then finally the configuration setup for the ADC. So always remember to disable your ADC before you configure it, and then enable it once you've finished. And then the analog read. So it's just reading our analog pin, begin sampling, once the acquisition is done, and then stores it in just in here. So we go back to our network source file. And we just continue to go down through it. So we've got 3 tasks within this code. As you can see down in here in the main, we're just setting up our processes, and then we've got the main in here. So we've got our task create, task 1, so that's our pointer to task 1. It's the name UART2, the stack size, and then not using these 2, and then the priority 2, and the same again for task 2 and 3. And then as well as that, we need to increment the scheduler, and then we've got a loop here, never-ending loop here, to just continue run the system. So we go down to our first task, which is our UART2. So within the UART2, we're initializing our integers char buffer of size 1024. Then pin select, so we're selecting our 2 pins on the TP32 board. So we're using for our receive, we're using RB8 and transmit RB9. And then here we're just configuring our UART2 and enabling it. So within this code here, we're just pretty much just copying this text here into the buffer and then transmitting it out onto the POTI. So we go to our while loop. What we are doing here, we are reading the analog read RB9 and placing it into our read. Then we're copying the read with this text in front of it and place it in the buff. And then we're transmitting this buffer out through the UART with a delay. We go on to our next task. So again, we're setting up our parameters at the start. Sorry, task 2. So within task 2, the same thing, we're setting up our pins. So in this case, we're using our receive to be RF4 and transmit to be R0. Configuring the UART again, and then transmitting this out, just so we know within the PuTTY that we are using the UART1. So then, in this case, when we go into our while loop, we are waiting here till the data is received. We're putting the data received into a buff and then putting it into RX size. And then we're transmitting this out through our other transmit, which would be UART2. And then as well as that, we're transmitting it to our other UART, so it will come up in both screens. So we've got an if anything is entered, so if our RX size is greater than 1, we will transmit a question mark on both the UARTs and then a return new line. And finally, task 3. So within task 3, we've got to enter your X. We're setting up our configuration pins here. So we're setting up RB15 to be an analog input. We're bringing in the configuration for the ADC. Then we go into our while loop, where we're reading the analog pin RB9, analog 9, and we're placing that value into X. And if X is greater than 500, we will output a 1 to RB4, which we have an LED connected to, which will light if it goes above 500. As well as that, we'll transmit an alarm out to the PuTTY on the UART1 and UART2. So that'll come up on our screen with 2 alarms, or else just no alarm and no transmits. Thank you.